Welcome everybody to this presentation entitled A User-Centric Evaluation of Smart Contract Analysis Tools in Decentralized Finance. So in the DeFi space, this work is the result basically of two of our DCU students that were on the master in blockchain, Gonzalo Faura and C-MRiC. I was their supervisor. So this basically is their thesis, the result of their thesis. The outline of my presentation today, basically I'm going to introduce the context of our research. I'm going to introduce it to our research objectives. Then I'm going to dive into smart contract analysis tool, a short overview, how we selected this tool for further analysis, the evaluation of these tools following certain criteria that was, or metrics or criteria that were identified by us, or criteria that was highly used in or well known in the literature. We are going to talk a little bit about the results that we have obtained following the analysis of these smart contract analysis tools, and then I'm going to conclude the presentation. So decentralized finance, what is this? This is basically a new financial system that knows now an exponential growth. It's $1 billion financial system. It's basically like democracy in finance. You can conduct financial operation without a centralized source like a bank. But obviously, with all new technology, there are issues such as, and some of the issues are rooted in the smart contract vulnerabilities, the smart contract that this DeFi ecosystem is based on. In our paper, we did a short analysis on, well, not that short, but kind of an overview of the attacks that were performed in 4 months time during April and July 2021. And only in this duration of time, these attacks led to a loss of around 343 millions of dollars. Even more recent statistics show that DeFi attacks are on a rise. So in 2022 as well. In the first 5 months, for instance, of 2022, 1.4 billion of dollars was registered in financial loss caused by DeFi attacks. So only in the first 5 months of the 2022. So then in this trustless environment, we asked ourselves if the smart contract analysis tools that were built to identify vulnerabilities, can be used by DeFi users. Obviously, in DeFi users, we know that when we talk about DeFi users, we know that most of them would be non-tech people with no programming background. So can these tools help the DeFi user protect themselves against vulnerabilities and financial loss? So we set two main research objectives. One was to provide a comprehensive analysis of the analysis tools currently available and make a comparison of tools used for verification and detection of vulnerabilities in Solidity smart contracts. And the second one was to determine to what extent existing tools can empower the DeFi users to verify the trustworthiness and security of smart contracts that will handle their investment. So as we said, we perform quite an extensive analysis in the literature review, but also we used various white papers and websites. We identify 21 tools for the purpose. Obviously, there are more out there, but for the purpose of our analysis. And out of these, we selected 6 tools to perform an even more thorough analysis on, and these were Slither, Mithril, DeScanner, Securify, Oyente, and Smart Check. Now, what was the criteria we used for the selection of these 6 tools from the initial 21 tools that we looked at carefully? Well, first was the availability of the tools. So some of the tools, some of those 21 tools that we initially analyzed were proprietary tools that we couldn't get access to. For instance, or some of them, they were deprecated. We analyze, for instance, their scanner was a proprietary tool, but we got access to that tool. So, and then another criteria was not require additional software like IDE. So obviously we had in mind non-tech users. So we did not consider plugins to the IDEs. So analysis tools that were built as plugins to various IDEs. We made sure that the analysis tools that we selected were able to generate output with warnings and recommendations again on the basis of the fact that our audience basically, so we address the non-technical users. We make sure that the tool is relatively new and actively maintained. So this is very important in this dynamic environment to make sure that our tool is able to identify the latest vulnerabilities. Successful installation and run. We encountered difficulties in using some of those tools that obviously for non-tech people would translate in even more or even more augmented difficulties. We also, another criteria was for the tool to be useful for all Ethereum smart contracts, so not to be any limitation there. Another way or another criteria, let's say, that we use in the selection of the tools was based on a survey that we ran within the community of the smart contract developers and auditors. So you can see here we presented the results of this survey. We looked at the experience of our participants in the survey as well. You can see there on the left. We had quite experienced participants. Most of them you see that have more than 2 years experience in this space of working with developing or auditing smart contracts. Now the results show that Mithril, MithX, Remix, and Slither were kind of identified as the most useful by the participants. Most of the participants chose to use multiple tools. So we can see that these tools are, nobody relies on a single tool when identifying vulnerabilities in smart contracts, which is a good practice, as we're going to see later on when we look at the results. Most participants, and as I said, most participants use more than one tool. Can I have the next slide? Yeah, thank you. A data set of 44 smart contracts was used, of which 28 contained 30 confirmed vulnerabilities and 16 others were considered healthy. And in the table there, we listed the vulnerabilities that were present in the smart contracts that were used for testings. So these 6 tools that we just presented in the previous slide were tested against this data set. It is important to mention that when we look at the literature review and at the taxonomy used to classify the vulnerabilities in smart contracts, there were multiple taxonomies present. So we decided to use the smart contract weakness classification one, so the SWE database, because we consider that is it's a live database and it's well maintained. So we used that one when we consider the taxonomy for the vulnerabilities. And then, as I mentioned before, we identified a couple of metrics to be used when we run the analysis of the tools that we identified. So we chose two well-known metrics, which were effectiveness and accuracy. But also we defined the metrics that were focused on the on usability. So such metrics, for instance, was installation metrics that looked at how easy, for instance, the process of installation and usage was, which is again very important when we consider that the users that we address are non-tech users. Another criteria, additional features. So it evaluates the selection of additional options and accessibility which make a tool easy to use. The liveliness, we looked if the tool is actively maintained. This basically metric that we defined was based on the commits and the activity on GitHub or those respective tools. Open source, whether the tool is open source, and if so, the number of community members involved. And also, we defined this metric called friendly output that basically evaluated how easy the output results would be for an average DeFi user to understand. So again, our non-tech users. Now, in terms of how we defined these metrics, so, or how we quantified them, we basically used a 5-point scale. Okay, and for each of the metrics that we used, including for effectiveness and accuracy. So for instance, for the installation metric, right, we awarded 1 if we were not successfully installing the tools, 2 or if the installation was cumbersome and had multiple dependencies, 3, only manual installation is available, 4, Docker image is available, or 5, this tool is based online and no installation is required. So this is how we defined this point. As I said, we defined, we use this 5-point scale for the effectiveness metric as well, and also for the accuracy. So for instance, in terms of effectiveness, we awarded 1 if less than 20% of vulnerability were found, or 5 if the tool successfully detected more than 90% of the vulnerabilities that were in the contract in our data set were identified. In terms of the results obtained, so this is basically a table that shows a summary for each of the metrics. So for instance, for Slider, it was awarded 4 for installation, 5 for additional features, 2 for effectiveness, 5 for liveness, 5 for friendly output, and his 5 as it's an open source that has a huge community behind. And we've seen that even from our survey, it was identified as one of the most useful tools by the developers and auditors. They participated in our survey as well. And 4 for the accuracy. And with a total of 30 points that, you know, like for all these metrics on our 5-point scale, it's and rated as 86% on the basis of this point, is the first is a tool that performed the best among the 6 tools. In terms of comparing with others, with other works in the literature, we kind of obtained let's say comparable results. With similar works that looked at the accuracy or effectiveness of such tools in the literature. From the tools that we analyzed, the C-MRiC performed had the worst performance among those. It was rated using all these metrics with 40%. Here is a table that shows the performance of the tools broken down per classes of vulnerabilities that we used. So we see the performance of each tool, for instance, liter metrill, the scanner, security-oriented smart checks for each of those vulnerability type for overflow, underflow, unchecked call, and so on and so forth. Some of the tools here, we see that they were not able to identify any of vulnerabilities in one particular class of vulnerabilities. And this is because some of those tools were not basically developed to identify those particular type of vulnerabilities. Hence, again, we want to underline the importance of using multiple tools when analyzing smart contracts. And to conclude the presentation, so my last slide with conclusion. In our research, right, we identified that the smart contracts in this space, in the DeFi space, are particularly complex. There are specific vulnerabilities to the DeFi space. We perform a quite a thorough analysis in our paper that I didn't really present here because we wouldn't have the space and the time. What we basically concluded is that specific vulnerabilities to DeFi environment cannot be currently identified with the smart contracts analysis tools. And also from the analysis that we presented, their effectiveness is reduced, the effectiveness and the accuracy both. Moreover, there should be an ongoing effort of upgrading these tools and keeping them updated to the new vulnerabilities that come up. Some of the tools that we highlighted are not designed to identify specific classes of vulnerabilities, so it's very important to look at this aspect when identifying the tools that we use for the analysis of smart contracts, to make sure that we don't leave specific classes of vulnerabilities outside of our analysis, and we choose a couple of tools to be used in our analysis. Another finding, another general finding of our research was that the tools are not really appropriate for non-tech users, such is the case of most of the DeFi users for various reasons, starting from the fact that some of them, they are just they don't have any user interface, or the result is very difficult to understand and to make sense of, or present too many information about the internal libraries and so on and so forth. Also, the high level, so the not high level, but the low level of accuracy. So the presence of many false positives would cause an issue for the non-tech user, who will not be able to know what is false, if it is indeed a vulnerability or if it's just a false positive. So in the end, more research is needed to increase the usability for both tech and non-tech users, and the effectiveness of these tools. So thank you very much for listening to my presentation.